Hello everyone, I'm Adam. In this problem, for a set of parametric equations, which we have as x equal to t plus 4 and y equal to t cubed minus 12t plus 6, we're going to find any points that we can of horizontal and vertical tangency to the curve made by these two equations. Then we're going to use a graphing utility to confirm our results. So first, let's think about where can we find points of horizontal and vertical tangency to a curve made by a set of parametric equations. Well, let's think, or start thinking, of a curve in general. Let's say we have our xy axis and some curve, not necessarily the one made by our equations here. So something like this. So as we see it, well, we can kind of see right around this point, somewhere about here, we'd have a point of horizontal tangency. So there'd be a horizontal tangent line. And about at this point, we'd have something looking like a vertical tangent line. Okay? Now, what do we know from regular calculus? Well, whenever we have a horizontal tangent line, the derivative is 0. Whenever we have a vertical tangent line, the derivative at that point is undefined. So now we're going to take a look at, well, what our derivative is, right, in terms of parametric equations. So the derivative, dy dx, is, we know as dy dt divided by dx dt. So thinking of this as a fraction, well, our derivative is 0 whenever the numerator is equal to 0. So we're going to have a horizontal tangent line whenever, namely, dy dt is equal to 0. And this derivative, or this fraction, would be undefined whenever we divide by 0. So we're going to have a vertical tangent line whenever our dx dt is equal to 0. So that kind of sets us up with a game plan. So if we want to find all points of horizontal tangency, so we'll start with that. Then, as we just said, that's equivalent to finding where dy dt is equal to 0. So we'll start with that. So what is our dy dt? So dy dt, looking at our y, which is t cubed minus 12t plus 6, taking the derivative of y with respect to t, so that's going to give us, say, 3t squared minus 12. And we want to see where that is equal to 0. Namely, we're going to be solving for t. Which values of t make this equal to 0? So solving this for t, well, we could try and factor it, or maybe we'll just solve for t directly since we just have our t squared term. So if we add 12 to both sides and divide by 3, we get t squared is equal to 4. And taking the square root of both sides, we get that t is equal to plus or minus 2. So when t is plus and minus 2, we get a point of horizontal tangency. So we're going to find that point in xy form. So let's start with, say, t is equal to negative 2. So all we're going to do is find our x and y values. So we're going to plug that value of t back into our original parametric equations. So x is equal to t plus 4, or negative 2 plus 4. So x is equal to 2. And y is equal to t cubed minus 12t. So negative 2 cubed minus 12 times negative 2 plus 6. So cubing, we have negative 8 plus 24 plus 6 is equal to 22. So our first point on the curve, where we'd have a horizontal tangent line, where derivative will be equal to 0, is going to be when x is 2 and y is, say, 22. Okay, so our first point. And let's see. So our next point, come over here, we want to find, say, when t is equal to positive 2. So again, x is equal to t plus 4. So 2 plus 4, and that gives us 6. y is equal to t cubed, so 2 cubed minus 12 times t, or times 2, and plus 6. So positive 8 minus 24 plus 6, that gives us a negative 10. So then our second point, where we have a horizontal tangent line, is going to be at the point x value 6, y value, say, negative 10. Okay, so that's our 2 points where we have a horizontal tangent line. And then the last thing we want to find is any points, if we can, where we have a vertical tangent line. So let's take a look at that. So a vertical tangent line, again, is when dx dt is equal to 0. So we take a look at what dx dt is. Well, the derivative of x with respect to t, x being just t plus 4, well, dx dt is just equal to the constant 1. Since it's a constant 1, we can see, well, that's never going to be equal to 0. So what that tells us, since dx dt will never be equal to 0, as far as points of, say, a vertical tangent line, we're not going to have any. So we're going to have, say, none. Okay, so there's our points of horizontal tangency, and we find that we have no points of vertical tangency. Now what we want to do is confirm what we found using a graphing utility. So taking our graphing utility, so first thing we're going to do is we're going to go into mode and make sure we're in parametric mode, and then go into our equation input, and we're going to enter in our pair of parametric equations. So for x, we're going to type in parameter t plus 4, or whatever your parameter is, and y, type in t cubed minus 12t plus 6. And then before we graph it, let's set our window. So going into our window, we'll set our parameter range, say t min from negative 6 to t max positive 6, and our t step as 0.1, or something just small enough to make sure we get a smooth graph. And our x range will take from x min of negative 2 to x max of positive 10, and our x scale of 1. And for y range, we'll take y min from negative 15 to y max of positive 25, and our y scale as 2. Then if we press graph, we see a curve being sketched out where it looks like we have a relative maximum and a relative minimum. So those are going to be the points, or candidate points, for the horizontal tangency, which we have as 2 points. And as it looks like it doesn't seem like we have anything, we're going to have a vertical tangent line. So now let's confirm this. So first, there's two kind of things that we're going to confirm. We're going to confirm that at our values of t equal to positive and negative 2, we indeed got the points 2, 22, and 6, negative 10. So first we're going to go to trace, and typing in the value of, say, negative 2, t equal to negative 2, we see it places a point right about where our relative maximum would be, and giving us the point x equals 2, y equals 22. So confirming that. And do that again, go back into trace, and typing in t equal to positive 2, and pressing enter. And we see it puts our point right at our relative minimum, confirming our point of x equal to 6 and y equal to negative 10. So for our given values of t, we got the points. Now what we want to do is confirm that the tangent lines would be horizontal, or the derivatives will be equal to 0. So we're going to do that by going into Calc, our Calc menu, and we see we have a couple of options. We can calculate dy dx, dy dt, or dx dt. Since we're looking at the horizontal tangent lines, you can do this one of two ways. dy dx and dy dt, you have a horizontal tangent line when either of those would be equal to 0. We'll particularly focus on dy dt. So select dy dt, And we're going to type in our value of t equal to -2 and press enter. And we can see it puts our cursor point right at our point where x was 2, y was 22, and it says dy dt is equal to 1 times e to the -6, which is approximately 0, which confirms that we would have our derivative as 0 or a horizontal tangent line. And we're going to find for the other point, go back into calc, select dy dt again, and now we're going to type in t equals +2 and press enter. And it puts our cursor point at around our relative minimum of x equals 6, y equal -10, and says that we have dy dt is equal to 1 times e to the -6, which again is approximately 0. We're confirming our derivative is 0, or we have a horizontal tangent line there. Now the last thing we're going to do is take a look at our vertical tangent lines. So we can visually see on the graph it doesn't look like we should have anything. Now if we go to Calc menu again and select dx dt, as we found in our problem, dx dt was equal to the constant 1. So for this, if we pick any value of t, let's just say the value of 3. So t equal to 3 and press enter, we get dx dt is equal to 1. And that should happen for any other value of t that we pick. So if we go back to the Calc menu, select dx dt again, and pick a different value of t, let's say t equal to 1, again we see dx dt is equal to 1. So meaning that we have a constant value of dx dt, or it's never going to be equal to 0, so we have no vertical tangent lines. So there we go. Thank you very much.